No. Oh, there we go. Hi. So welcome to Effective Testing and Testing Effectively. This is Teddy. My name's Kath, and I've been in tech for almost 30 years. I've been in the back-end PHP space for probably about 18 of those, and Laravel since around version 5. And today I want to cover off kind of 3 parts of the testing experience for developers. Speed. How do we test the most things in the least amount of time? Because if our test suites run slow, we're much less likely to run them at all. Next, coverage. It's no use having speedy test suites if they're not really covering much of our code base. But we want to make sure that that coverage is impactful. So understanding the difference between unit, feature, and integration tests, why you need all of them and how they fit together, is going to help you make the most bang for your buck in the things that you do devote time to covering. So we'll start with speed. It's not magic, it's mechanics. Every time you run your test suite, every test that runs has to go through a little journey, and there are a bunch of cogs along the way that we can oil to make that journey quicker. And generally, the slowdown is not actually in the test itself or your assertions. When we run pest or PHP unit, I'm probably going to default to saying pest because that is what I use, but these concepts are equally applicable to both. We begin with a framework boot. We've got to hoist your entire Laravel application. That will, by necessity, generally include some database setup. I'm talking both the creation of the database schema itself, then any data creation that happens as part of your setup lifecycle. Then into your tests, they're probably going to call some of your code. There may be some external interactions where you're doing something that calls an API or a mail service. Then finally, you'll be onto your assertions. Did the thing that I expected to happen when and how I expected it to happen? And then we have to tear down all of that scaffold, rinse and repeat. Every single test you write goes on this little adventure, and some of them go a little bit more scenically than others. Each part of the adventure is an opportunity for us to optimize for speed. And I'm going to talk about some of the major expense points in this. Firstly, build less castle. If we're having to build the whole Laravel application, hoist the whole framework every single time, let's try and do as little of that as we have to. So things that are unlikely to change during your test run can be cached. I'm not sure, Jess, you've done me in. So I'm talking your views, your configs, your routes. None of that should change in between tests, so cache it all before you're even hitting pest or PHP unit. Next, plant carefully. Another huge slowdown I see, and I literally fixed this in a code base a couple of weeks ago, is running large unwieldy seeders in the based test classes setup method. So when you are seeding entire swathes of lookup tables for every single test, even if you're not going to look at them in that test. Database I/O is expensive. Make sure you avoid doing it until you have to do it and do the least amount of it for your particular test case. If possible, avoid the seeders altogether. Prefer factories. If you are using Refresh Database and you are not trying to parallelize your tests, consider using transactions. I do understand there's some finicky stuff with parallel runs and transactions, but look critically at your database interactions during that setup cycle and see what you can minimize. Next, the big one, mock things. I love Laravel for this. Anyone that has worked with me for any period of time will know that I am a massive fan of facades, in a large part because they allow really easy mocking of your services and methods. So when we're writing our tests, one of the big things to keep in mind is that what we're testing is our own code and business logic. We do not need to test the framework. That's Taylor's problem. We don't need to test the vendor code. That's the vendor's problem. And we don't need to test If MailChimp is up, we just need to test that our code could interface with it if it was. So I see a lot of test suites that are actually trying to make live calls to external services, and again, network I/O is an expensive operation. Ditch it, you don't need it. Mock the call, say, hey, test suite, I expect that I'm going to get a request to go out to abc.com, and I expect that I'm going to get a response of XYZ. Mocking also allows you to make more impactful tests because you can mock for a variety of scenarios. What happens if I get a good response? What happens if I get a bad response? What happens if I just don't really get one at all? Does your code cope with all of those scenarios? Mock anything that you're not directly asserting on. I'm talking, mail queues, job queues, all of the buses in Laravel, mock it. Finally, when we're optimizing for speed, the best place you can start is actually to measure where you're at. Understand where the critical points in your particular test suite are. What is actually taking the most time? I think it can be incredibly tempting to just look at your existing outputs and go, pretty sure the problem's there, and then we sink 2 weeks into there and find out it was actually there, and that's 2 weeks we could have spent over there, but we spent it there. So measuring for speed doesn't have to be complicated. You absolutely can use profilers. You literally could also just output a bunch of log timestamps throughout your setup function and look at the delta between them. What is taking the longest amount of time to get from A to B to C? Pick on the biggest one and say, yep, I'm going to aim to reduce that by 50%. Focus your efforts there, iterate and repeat until you've oiled that cog, and then move on to the next one. Obviously, I'm not advocating that you actually ship these log methods into your code base, but absolutely use them while you're developing. I never thought I'd say that because I'm an ex-debug girly. However, you might be here. And I think that has been most of us at some point, where the tests that your application has are the 2 that you get for free when you Laravel new, and that's it. This is actually an opportunity, not a crisis. It's an opportunity for you to do it thoughtfully from the beginning. Because ultimately bad test coverage, it's us, we're the problem. And while that speed portion is very mechanical, this part, increasing our test coverage, is actually a lot more squishy. It's about people and attitudes more than it is about process and tooling. Because increasing our test coverage requires us to have some new rules and some new attitudes about the way we approach our development. Firstly, an attitude of progress, not perfection, is absolutely critical. You are not going to get 100% test coverage in your large, sprawling 10-year-old application overnight. Stop thinking that you can. So commit to incremental increases. Commit that as a team, testing now becomes an integral part of your workflow, not an add-on or something we do if we have time. When someone asks you how long it will take to do something, think of how long it will take to do something and test it, and that's the answer. Tools like CodeCarve can be great as an addition to your pipeline to highlight, are you actually increasing over time? However, we want to look at all of those kind of metrics with some nuance because not all percentage points are equal. I'm going to show you 2 pieces of clothing, and I want to imagine these are your choices in your wardrobe when you got dressed this morning. You are wearing a t-shirt, you have nothing below the waist, and these are your only 2 options. There are no knickers. You can have 80% coverage. Or you can have 40% coverage. Who would like to walk out onto Queen Street in 80% coverage? I'm shocked. None of you, because that 40%, that was the critical 40% of this application. So that brings us to where am I focusing my efforts when I have time to, backfill tests. And I've split this into two things. I think what I call high-use critical function, these are the things that if they do not work, your application might as well be offline. So if you are an e-commerce site and you cannot process payments, you are probably dead in the water. If you are an application monitoring service and you can't send alerts for things that are down, who cares if your dashboard looks pretty? And this is about knowing your application inside out, not just technically, but functionally. What is the business case for it? What is important to your users? What is the thing that they need it to do and do reliably every day? If you have any spare time and you don't have coverage there, start there. The next portion is what I've called high-use critical reputation. These are the things that, although technically your application works, they're going to be incredibly damaging to your business if these things happen. So your e-commerce site is online, it's processing payments, and they went via HTTP. I mean, it worked, right? We sold something. And now a bunch of people on the internet have your customer's credit card and they're real mad at you about it. This is critical reputation. Or, your monitoring service sent out an alert about a half hour after the phone was ringing off the hook because all your customers couldn't find your site because it was down, but you didn't know about that until just now. Again, it technically worked, the alert was sent, but not in a timely manner. Be aware of what is reputationally important or, really going to create a bad friction experience for your users. Add more tests there. So, we've talked about, if we've got spare time, what is this concept? But apparently some of us have it sometimes. This is where we're backfilling tests. But I think the big shift attitudinally as a team comes in the form of what I've called bug spray, which is another way to think about test-driven development. Commit as a team to a cycle of break, test, fix. This is a promise that you make that no user is ever going to encounter the exact same failure more than once. And how are you going to guarantee that? You're going to guarantee that because once we've got a bug, we've validated it, we've said, yep, we're going to spend some time to fix that. The very first thing you'll do before you fix it is you'll write a test that would have prevented your user encountering it in the first place. So you write a test that fails. If we'd had this test, this particular code set would never have got to production because the test would have failed. And only then do you fix the problem in the code that's causing the failure. Now all of your tests pass again. And now you can ship with confidence that not only have you fixed it, but you're in a great position to catch any future regressions. Some other change that future you makes is not going to create this same breakage ever again because you will know about it before a user hits it. And as you're applying your bug spray, be open to incremental refactors that aid testing. I think, my colleagues have talked this morning about the value and importance of writing idiomatic Laravel. What do I mean by that? Writing Laravel the Laravel way, because that is what all of our tools, both first-party and third-party, are built to support. That is what conferences like these are going to tell you tips and tricks for. The more that your code base is massaged towards the Laravel community standard way of doing things, the easier you're going to find it to write tests. If you're dropping facades in front of your services, you've got a bunch of built-in mockery functions. If you're sending mail using Laravel's mail queues, you've got a bunch of mail faking you can use. So whenever you can, as you're applying your bug spray, see if you can make some changes that move you further towards the standard, not away from it. And finally, please, for the love of everything that's good, don't test the framework. As Michael so embarrassingly publicly reminded me about 18 months ago when I jumped into PHP Australia Slack and I was like, hey, having this real problem with this test. I'm doing acting as, and I've got this event listener for the logon function, and none of my assertions are working. I don't think it's firing. And he just, in the Michael way, was like, why are you testing the framework? I'm not testing the framework, I'm testing my handler for the event. And he's like, but you're not, because your problem is the event being fired or not, which, spoiler, it's not if you do acting as, that doesn't actually perform a login action. And I was hung up on the event not firing rather than trusting that the framework will fire the event if I'm logging in. I just need to be triggering my handler and seeing that it does the things that I expect it to do. And this next section, as we get into exploring different kinds of tests, I think helps you think about where the boundaries are between your application code, vendor code, and framework code, and ensure that you're only testing yours. So, units and features and integrations. Oh my. I think maybe I got that quite wrong. So, what are they? Unit tests test the single smallest unit of code. We're talking a single class or even a single function. Just does this particular widget look and behave the way I would expect a widget to widget? They're great because they're small, they will catch logic errors early, they're generally fast, but they do miss things because they've got no concept of larger structures, user flows, or how anything fits together. Feature tests take us one step further. We take all of our good bricks from our unit tests and we build them into a structure. I like to think of a feature test generally being bounded as a single HTTP lifecycle. Can I make a request to hit a single route, something happens, and I get an expected return? So we saw one in Jordan's talk that assert that I can hit the dashboard as an admin and I got an OK feature test. Can I post a bunch of data to a CRUD endpoint and something happens in the database? Feature test. That's probably covered off some interactions between a controller, a request, some validation rules. And then we build those into the whole castle, an integration test. These would generally describe an entire user journey flow. For example, I signed up to the website, paid my subscription, and I got a confirmation email. Or I went to the login screen, I clicked on forgot password, put in my email address, and I got a password reminder email. All of these kinds of tests help us to catch different things in our application, and they're all equally important. So I'm going to ask a couple of my friends to come up and join me because we're going to have some show and tell, and I'm going to make them eat some things on stage. And this is going to help us to understand what these different types of tests are, how they work together. And please welcome, thank you, this is my friend Gary Yeatman and, of course, the very visible invisible developer, Marty Friedel. So, gents, if you could open your unit test bags. Now, Gary has 2 plastic Lego branded bricks. And Marty, what have you got?
They're a little tad sticky and a little gummy.
Okay, but do your bricks have studs on the top of them?
They do indeed.
Yes, and Marty? Yep. And are the studs in a 2x2 pattern and there are 4 studs each?
Yes.
Yes.
Okay, and if you put your bricks together and try and snap them apart, did they snap apart cleanly?
Yes. Not really.
A bit sticky?
Bit sticky.
Yeah, all right, we'll eat those. So we've seen the unit tests passed for both the bad bricks and the plastic bricks for some of them. And at the end, things came a bit unstuck, too stuck, very sticky. Sweet, oh, perfect. Are you guys hearing the guys okay? Yeah, cool. So we're going to bring our bricks together to make a feature test. I think Marty will have the tower on the left, and Gary, you should have the tower on the right. Are you guys all right to pass this between you? Cool, thank you. So, how many bricks are in your tower?
4.
You can't eat that one, it's plastic.
I didn't put it in my mouth, but...
Thank you, please don't. Cool, 4 bricks, and does your tower stand up straight?
It does.
Perfect.
Yes.
And that goes together the other way.
The other way.
Yeah.
Confused.
Like that.
Perfect, thank you.
Excellent, thank you.
Failed the test.
I did fail the test. My test was a bad test. And if you could just show the audience your towers, and if you shake them around, do they stay together?
No.
Okay. So we could kind of build some things with a gummy brick in them, but they didn't really hold weight. So we're going to go for the whole-ass castle. If you could open the yes, you may eat your gummy brick. And so they each now have a completely plastic tower. So this would be the point we're at where all of our individual brick tests passed, our feature tests have passed, and we now want to bring them together into a whole flow. So could the two of you try and build a tower, build a bridge between your 2 plastic towers?
It's a lectern fail here.
It's a lectern fail.
Lectern fail, yeah.
Oh my goodness. Steady.
Yeah, it's not going to work. Okay, let's go to the floor.
All right, floor. I mean, are you even playing with bricks if you're not down on the floor playing with bricks? All right, yeah, can you build a bridge?
How many more are there?
Okay, yeah, we have managed to get 2 gummy bricks slightly offset onto each tower, and the towers are close together. And then we're trying to put them together, and it is not holding weight, and the whole tower has fallen over. So, let's do it again.
The test. That'll pass this time, right?
It might be a flaky test. Sure, rerun the test. Okay, yeah.
How wide does it bring?
Look, the audience is just saying to ship it as it is. It's not a flaky test. It just fails. I wouldn't eat those. They've been on the floor.
There's more back there.
Yeah, there's more back there. Okay, cool. Thank you, gents. Where is my box? Okay, cool. Thank you. So the failure of the integration test might illustrate, for example, we hit a route, we set something in the session, we then did another intermediary step, and then we got to 3rd route, tower C, expecting the session variable to be intact, but something in B nuked it. Individually, if we'd tested each of those components, they probably wouldn't have failed a feature test. But when we tried to stitch them together, we saw that in an entire flow, the flow fell down. But wait. There is one other kind of testing that I think it's important to discuss, because this whole talk has been focused on the tests that we write, automated testing of our application. Why do we do that? We do it for users. And there are things that automated testing is never going to catch. And so I don't want you to come away from this thinking, Kath said I don't need QA people anymore because I just have to write a bunch of unit, feature and integration tests and tick, I'm done. That is not what I'm saying. I'm saying we leverage the computer and the automated testing for the things that we can automate so that we have the people power to test the things that we can't. Automated tests tell us how our application behaves in a very empirical, measurable way that is repeatable. They reduce the burden on human QA for rerunning test scripts and regressions. QA people tell us how our application feels. Is an element, present on the page? An assertion would say, yes, it rendered, but it's 1,000 pixels that way and nobody can see it. Or the contrast on your colours is really terrible and nobody can read it. We know the string rendered because the tests told us that, but the QA person said, hey, this doesn't make sense. We still need those people. And with that, I would like to thank you for letting me embarrass my friends on stage. Are there any questions? Sure, Michael's here somewhere.
Playing with Lego.
Oh, can I have the Lego, please? Cool. Does anyone want Lego? Are you inspired to do some testing? Oh, this is going to test my throwing arm now.
Would you like some help with that?
I would love some help with that. You've got a much better throwing arm than I do. Michael told me I was not allowed to throw this box, so I'm just going to drop it down there. You can buy those at Coles and Woolworths if you want them.
Excellent. Great job.
Thank you.
Thank you for expanding on the earlier presentation. Do you have any recommendations around parallel testing and like whether you're using lazily refresh database or refresh database? Like do you have a hard and fast rule?
I do not have a hard and fast rule. I think what works for you is what works. I would probably prefer building the schema once and using transactions to roll the data back and forth than rebuilding the entire data schema every time, which is what a refresh database would do.
Do you have any resources off the top of your head for testing that are not on YouTube or Laracast? Is there anything?
As in that's not a video? This is my people. I hate watching videos. Honestly, you're going to hate me. RTFM, like the docs are amazing.
All right, and last one, how do you prioritize areas of an application to start testing?
Okay, I feel like that, I hope, was in the middle of the talk, but the things that are really critical, what's the point of your application, and do you have tests that make sure it does the thing? If not, start there. That's your priority.
Fantastic.
Cool.
No worries. Thank you very much,
Thank
Kath.
you.